So if you have to calculate the numerical on bevel gear design, you should follow this step-by-step procedure. If your numerical says to design the bevel gear pair or to calculate the module, then you should use step-by-step procedure. I have also included the information that on which page number of Bhandari design data book, which formula is there. So if your numerical says two shafts are at right angles to each other means it is a bevel gear, are connected by bevel gear pair having full depth involute teeth. So full depth involute teeth means we are going to assume 20-degree pressure angle. A pinion having 20 teeth, ZP is 20, transmits 40 kilowatt. So your power is 40 kilowatt. You have to convert it into watt at 750 RPM. 750 RPM means your NP, number of RPM of pinion, is going to be 750. Running at 375 RPM, your NG, number of RPM of gear, is going to be 375 RPM. Allowable static stress for gear and pinion. See here directly, instead of SUT, ultimate tensile strength, they have directly given your bending strength, allowable static stress, sigma BP and sigma BG. They have given sigma BG as 100 Newton per mm square and sigma BP as 70 Newton per mm square. We have to determine the module, pitch circle diameters and face width from strength conditions. Strength conditions means we are going to only use the beam strength equation. We are not going to use the wear strength equation because they have clearly mentioned you have to only calculate on basis of the strength conditions, means beam strength condition you have to use. Given data ZP, number of teeth on pinion is 20, NP, RPM of pinion is 750 RPM, sigma BP is 100 Newton per mm square, power is 40 into 10 raised to 3 watt, NG is number of RPM of gear is 375 RPM, and sigma BG, bending strength for gear, is 70 Newton per mm square. First we are going to calculate the number of teeth on gear ZG. We have NP and NG 750 and 375. We also have the number of teeth on pinion ZP as 20. So by cross multiplication, you will get number of teeth on gear ZG as 40. This is on page number 17.3 of Bhandari design data book. Now your pitch angle of pinion, that is gamma P. You have to find out the formula 10 gamma P is ZP upon ZG is equal to DP upon DG. Right? So your pitch cone angle is 20 upon 40. So you will get as 26.56 degree. Formula is there on page number 19.1 of Bhandari design data book. Next, same you are going to do pitch angle for gear, right? Which is ZG upon ZG. So you will get it as 63.44 degree. Next, you have to find out the virtual number of teeth, Z dash P, which is actual number of teeth, ZP upon cos gamma P, and Z dash G is ZG upon cos gamma G. You will get the values consequently, Z dash P as 22.36 and Z dash G as 89.46. Now you have to find out pitch circle diameter for pinion and gear. DP is MZP and DG is MZG, right? So in this we are given ZP and ZG, so DP will become 20 module and DG will become 40 module. Now I have to assume the face width. Here the face width is totally different from spur gear and helical gear. The formulas are there on page 19.3 of Bhandari design data book. First you have to find out the pitch cone distance, which is under root of dp by 2 whole square plus dg by 2 whole square. dp is pitch circle diameter of pinion, dg is pitch circle diameter of gear. So we have dp as 20 module and dg as 40 module. So you will get A0, that is your pitch cone distance, as 22.36 module. Or your face width is going to be either 10 module or A0 by 3, that is your pitch cone distance by 3, whichever is smaller. So face width, whichever is smaller, that value you are going to take. So if we do both of them, 22.36 by 3 module or 10 module, you will get 7.45 module or 10 module. Obviously between 7.45 module and 10 module, 7.45 module is smaller. So we are going to take face width as 7.45 module. Third step is to calculate the bending strength, which is SUT by 3. Formula is there on page number 19.3 of Bhandari Design Data Book. We don't need to do this step because already the allowable static stress, that is your bending strength or bending stress for pinion and gear, 100 megapascal and 70 megapascal are given. So you don't need to do this step. For 20-degree full depth pressure angle, they have said in the numerical that it is full depth pressure angle. So we will assume 20-degree full depth pressure angle. So your Z-P and Z-G we already have found out before. So just putting the values into the formula of Y-P and Y-G, we will get Lewis form factor for pinion Y-P as 0.3556 and Lewis form factor for gear Y-G as 0.4519. Formula is there on page number 19.1 of Bhandari Design Data Book. Which is weaker, pinion or gear? Now this step, if the pinion and gear material are different, obviously here sigma B, that is your allowable static stress for pinion and gear, they are given different. So you will have to do this step. So if I find out sigma BP Y-P, it is 100 into 0.3556, which is 35.56, and sigma BG Y-G is coming 31.63. Obviously you can see sigma BG Y-G value is 31.63 is lesser than sigma BP Y-P, which is 35.56. So gear is weaker in design. Right, so gear is weaker than pinion in the bending because we are only going to do the bending strength. Beam strength is formula is MB sigma B Y 1 minus B upon A0. Right, so if I put down all the values properly into this formula, I will get beam strength as 157.67 module square. Seventh step is wear strength, but we are not going to do this because clearly in the numerical data they have mentioned that module should be calculated on basis of the strength conditions, means beam strength conditions. Hence tangential load, for that we'll first calculate the pitch line velocity. V is pi dp np upon 60,000, so pi into 20 module into 750 upon 60,000, so it is coming 0.7854 module meter per second. So power and velocity both if I found out, then I'm going to get tangential load Ft or Pt as 50929.46 upon module Newton. Next, I'm going to assume service factor and load distribution factor as 1 because they are not given in the numerical. And for velocity or Barth factor, I'm going to assume that straight bevel gears manufactured by generation. So for straight bevel gears manufactured by generation, it is 5.6 upon 5.6 plus under root V. For effective load by preliminary estimation, if I put the values of CS, CV, PT, I'm going to get effective load as 9094.54 into 5.6 plus 0.8862 under root module upon module. So if I use the beam strength equation, FB is FOS into F effective, I'm going to get this equation. M cube is 484.52 plus 76.67 under root module. You have to solve this by trial and error equation. Let us see how to solve this by trial and error method. For trial and error method, I'm going to keep M as cube root of 484.52 plus 76.67 under root M. Wherever there is M in your calc, instead of M you have to write down answer. You can see in the video how it is done. It is shown properly what you have to do. You have to do what? You have to write down this as, you have to write down cube root of 484.52 plus 76.67, and in calc you have to press under root of answer. You have to close the brackets and keep equal to. You will get answer as 8.9. Right, so your module you cannot select it into the decimal points, so we will select the next higher value. Module is 10 mm. Next you have to calculate all the dimensions of the gear pair, your module, your ZP, ZG, face width, put down the value of module into that, you will get 75 mm. DP/DG, put down the value of module, you will get it as 200 and 400. Your pitch cone distance, put down the value of module into that. Your addendum, dedendum, and your cone angles, pitch angles, gamma P and gamma G. So step 1, we calculated the number of teeth on gear. Step 2, we assumed face width. Step 3, we calculated the bending strength. Step 4, we calculated Lewis form factor. Step 5, we decided whether pinion was weaker or gear. Step 6, we calculated beam strength. Step 7, we don't have to do it over here, but usually you have to calculate the wear strength. Step 8 is to calculate tangential load. Step 9 is to calculate the service factor, load distribution factor, and velocity factor. Step 9, you have to calculate the effective load based on preliminary estimation. Step 11, you have to calculate the module, and step 12, you have to calculate the dimensions of the gear pair.